why don't we we'll go ahead and get started. And so thanks everyone for coming to the advanced webinar. Um, Let me get to this next slide here. Just a couple of reminders. If you can, if you don't mind, is to mute your audio during the presentation. But you can definitely put questions in the chat area or do a hand raise. And Alex can certainly answer your questions. As we go through this. I think Alex, he has a presentation, but it's also there's the informal side of if you've got a question and you want to, it's relevant to something you're seeing, then raise your hand or put it in the chat. Great if you can have your video on. That's always nice so everybody can see each other. We are recording this and we will make the link available for the presentation for those that provide their email and their name so that we can send that link to you. The top, sort of the three major topics that we're going to cover here, or Alex is rather, are what are called cloud structures and weather fronts and how they interact. Cloud structures, simple things like you see a shape of a certain cloud in a certain color, and what's that mean? What is probably coming your way, or which way, or going the other way? And then, analyzing clouds and looking at surface charts. And all of this, is to make make you a safer and a more informed, sailor. And even if you're not sailing, it's just information that you can use every day. And there's some pictures and charts that you'll see that the next time you see them on the news, or you go outside, you'll think, oh wait, Alex talked about that, and now I know why it's useful. Just if you want to get the name of the website where the company that Alex is with, it's WRI, and it's WRIWX.com. And I'll just turn that over to you, Alex, for our advanced class.
All right. Well, Hugh, thank you so much. So for those of you who are joining us after the first discussion, who attended the first, welcome back, and happy to have you here. For those of you who are just joining us for the second part, welcome, and looking forward to having this discussion with you tonight. So for those of you who were not involved with the first discussion, my name is Alex Avalos, as Hugh said. I'm an operations manager and senior meteorologist here at Weather Routing Incorporated. So this discussion is going to be a little more involved and more in depth than the first one we had talked about, which focused more on nuts and bolts. How to read a surface map and different types of satellite imagery, being able to interpret surface data. This one's going to focus more on your perspective on the water. So, of course, we're going to go over the various types of clouds that exist and how those can be used to determine or get a better understanding of what weather might lie ahead of you. But it's also going to go over, the things you can do to prepare for your passage out on the water, because, of course, weather has a mind of its own sometimes, and doesn't exactly stick to a rule book. We'll also go over some of the common challenges that you might find out on the water, geared especially towards areas of the Caribbean that can affect a smooth passage. Cloud progression, and we'll talk about, the applications of the surface analyses. So basically, what kind of clouds can you expect to see given various weather features that are in a given location? Some of the most common severe weather concerns and how to prepare for your trip and observe the signs of changing weather. We'll also at the end of the discussion, we'll go into more detail about, how having a weather router can help you with the decision-making process. So that'll be at the very end. And I'll wrap the discussion up with further talk on our supplemental platform called SeaWeather, and how you can reach out to us if you are interested in trying our services out. So the first topic we are going to talk about here in this second part of the webinar tonight, it would help if I shared my screen. 1 second. There we go. All right. So the first topic, like I said, we are going to discuss is on the matter of cloud progression and the behavior of these clouds. So obviously, when you look at clouds in the sky, they can tell quite a story. Sometimes they can be benign and unremarkable at any given time. But then there are also sometimes indications where you'll see clouds in the sky, and that can indicate that there's hazardous weather on the way. So we'll go over that here and how you can, read those clues in the clouds to inform you of any changes to the weather, especially as it changes for the worst. So cumulus clouds, of course, the first cloud type we're going to discuss here, on their own, they're really not a significant concern, pretty unremarkable as a matter of fact, and that they're just present in the sky. Oftentimes, they won't really indicate a significant concern. They can indicate that there is moisture in the atmosphere, but it tends to be more limited. One of the things that could be approaching is a weaker cold front. In the presence of at least some limited moisture, they can indicate that some instability is present, which is one of the ingredients that is necessary for thunderstorm development. And so when instability is coupled with moisture, that can give way to approaching, thunderstorms that are often in association with cold front passages. So cumulus clouds have that cotton-like appearance to them. You can see they look like cotton balls in the sky. Usually you'll find them in clusters with other cumulus clouds, but there can be times when moisture is really limited, that they tend to be more isolated in the sky. Now, these clouds can evolve into a more significant cloud called a cumulonimbus cloud. And what these develop in the presence of greater instability and surface moisture. So for those of you who attended the first talk, you'll remember we talked about the CAPE index. A high CAPE value indicates extreme instability. That's certainly one of the ingredients that you need for cumulonimbus development. It's not the only one, but it's an important component. And if you don't have it, certainly that further hinders the ability for these clouds to develop. But cumulonimbus clouds are obviously, a primary cloud for thunderstorm development. And when you have these clouds developing, they can produce thunderstorms that are capable of damaging wind gusts, sometimes large hail, and even water spouts. These structures are very common ahead of cold front passages. So how does a cumulonimbus cloud get that anvil shape? Well, basically what happens is when parcels of air are rising, they are essentially condensing. Warmer, less dense air is rising and then condensing within drier, more dense air. And that's where you get the clouds to develop to begin with. But what happens is they'll hit a stable layer at the top of the troposphere, which is inherently unstable, but the stratosphere is more stable. So the parcels of air can't rise any further, so they fan out. And when you get that fanning out effect, basically what that means is you're going to get an anvil structure with these. And you can see that's what's happening in this example here. Basically, the cloud couldn't rise any further, so it has nowhere to go but outward. And these clouds can grow very tall as well. Sometimes they can grow anywhere from 10,000 feet to as high as 52,000 feet. But in some rare cases, they can grow even higher than that. I can speak to experience where living in Wichita, Kansas, and for those of you who've been out in the plains, you'll know how flat and open it is. The Colorado border is a good 3 hours away, but you could see, the tops of the cumulonimbus clouds all the way on the Colorado side of the border. So they can grow very tall, especially out in that part of the country. And it's not out of the question that they reach some impressive heights. But they can become very visible to anyone who might be out in the open waters of the ocean, or even in a large lake, like say Lake Michigan or Lake Huron or Superior, for example. You can generally identify them from a distance. Now, cirrus clouds tend to be considerably more benign than cumulonimbus clouds, but they certainly have a story to tell because they do indicate that there is approaching unsettled weather. Now, not necessarily in the form of thunderstorms or severe weather in that nature, but you certainly can be looking at scenarios where you might be looking at rainfall approaching. For some this time of year, winter storms. Usually you'll find them anywhere at an altitude between 10,000 and 60,000 feet above the ground. These clouds tend to be much thinner, and basically with that thin layer, you tend to have very high concentrations of ice. Think that the temperature decreases considerably with height at 60,000 feet. It's going to be quite cold. When you have a warm front passage, that's usually indicative of the presence of these clouds because of that increase in moisture. But the clouds can become more dense as a result. And usually it's within 24 hours of a system in question that you'll begin to see these clouds develop and increase. So after that, altocumulus clouds tend to be next. These tend to be lower based than the previous clouds we've talked about, with altitudes generally between 7,000 and 20,000 feet above the surface. But unlike being made up of ice crystals, these tend to be made up of tiny water droplets. But they can still turn into ice crystals depending on altitude. Certainly the higher up in altitude, the more likely that becomes a reality. And while they are puffy and cotton-like in structure, they're certainly not as puffy as cumulus clouds are. These tend to occur after warm front passages and tend to be more common within 12 hours of the onset of a system and any rainfall or other precipitation that may be bound to occur. Usually you'll begin to see, when the weather is moving overhead and is imminent, nimbostratus clouds will tend to become more common. These are relatively lower altitude than altocumulus. And basically what happens with these clouds is lower visibilities can reduce, and that's partially because of the fact that these clouds tend to be closer to the surface, but that can also be because of heavier precipitation, which results from these clouds, which on its own can also reduce visibilities and can even result in the development of fog. So usually when the weather is deteriorating, you'll begin to see the visibilities drop. You'll begin to see precipitation increasing in intensity. And then, you might even have areas of fog. But as the weather improves, visibility goes up, precipitation and intensity both decrease, and you tend to see these clouds clearing out. Excuse me. So back in the last discussion in the Weather Basics webinar, we talked about surface analyses. Surface analyses, to reiterate, are a very useful resource to construct a self-weather briefing. But basically, when you have a knowledge of what weather features are in the area, you can basically take a look at what's ongoing in the sky to give you clues. And so these next few slides are going to discuss the common cloud types that you would see in given weather scenarios that I'm illustrating by this front, these surface analyses. So first, we're going to look at high pressure ridging. And you can see when you have high pressure ridging, you might recall from the Weather Basics discussion that that's associated with benign weather. You're not really seeing ample moisture or instability with the presence of a ridge of high pressure. And even when you do have enhanced instability, you're not really seeing a trigger that's going to serve as a focus point for thunderstorm development. Areas of high pressure are marked by sinking air motions, and you need that lift or upward motion to get that instability. So when you have those sinking motions, that tends to indicate stability and the absence of the necessary mechanisms for thunderstorm development. But basically, cirrus and cumulus clouds tend to be most common. Usually the movement of these clouds can be variable, and that's owing to the fact that there's not really any significant steering currents aloft to carry them in one direction. So think of with an approaching front, clouds will generally be approaching from the west and moving over a given area in that point in time. So as you'll recall from the Weather Basics webinar, troughs of low pressure basically indicate a wind shift. They're not really indicative of a temperature change, but they can still result in unsettled weather. And usually with troughs, you tend to get some risk for cumulonimbus clouds, but you can also get altostratus clouds as well with these. And that can result in intense rainfall or precipitation. But usually you're not going to get widespread violent weather in association with them because they serve primarily as a wind shift boundary and not a temperature boundary. Think about how that temperature gradient, when there's a significant difference ahead of the front versus behind the front in terms of temperature, that usually indicates a very strong front moving through, and the greater likelihood of weather to be severe. But because there's really not a change in temperature, you don't have that extremity to contribute to severe weather. But it's not unheard of. It can happen. It's just much less common than with cold front passages. So with cold fronts, as you can see by the dotted blue line with the blue triangles, these tend to be, mark a wind shift and also a temperature change. But as it is with cold fronts that you tend to get the more volatile and severe weather. Cumulonimbus clouds tend to be by far and away the most common with the strongest cold front passages. And as you'll recall from earlier in this discussion, they give rise to thunderstorms, which can be strong to severe. But fortunately, the good news is they do offer advanced warning time, and that is largely in part due to the fact that they can grow very tall, so you can see them from far distances. And basically, systems tend to move west to east. So if you are to the east of these cumulonimbus clouds, you will generally want to, get off the water. But it can vary too. You'll want to take a look at the direction of the wind. If the wind is coming out of the southwest, and you see these coming in your direction from the southwest, that's another clue that you would want to, get off the water. But they're characterized by their classic anvil shapes, as you'll recall from earlier in this discussion. Warm fronts are generally more benign than cold fronts are with respect to the approaching and passing weather, but they still can indicate the clouds that are associated with them, such as altostratus clouds, can give way to unsettled weather and provide those hints for you. And such concerns can result in heavy rainfall occurring, as well as rumbles of thunder. But like I said, because they're a more benign counterpart to their cold front passages, severe weather is far more uncommon. And you can still get rumbles of thunder with them, but again, it pales in comparison. And you can see that in this surface analysis, the warm front is basically indicated by the red semicircles moving northwestward. So we're going to talk a little more now about, preparation for being out on the water and what you need to look for changing weather conditions. So these next few slides, I'm going to talk about, how the, red sky in the morning basically is an indication. As they say, red sky in the morning is a sailor's take warning, but red sky at night is sailor's delight. So when you look at the sky, and it's red, and in the case of the morning, it's caused by an abundance of water vapor in the atmosphere. And that water vapor is usually associated with approaching storm systems, because these storm systems have such a high moisture content that leads to water vapor occurring out ahead of them. And so the water vapor present does result in cloud development, but basically the sun is scattering off of those water vapor molecules, and it gives it that beautiful reddish color in the morning. So because weather usually moves from west to east, what that will mean is that these clouds and hence precipitation will also be moving in from the west if the red sky is visible during the morning. But in the evening, it's sailor's delight. Basically, what it means is that, the weather is moving eastward and out of the affected region, and it's taking, the associated water vapor molecules that are reflecting off the clouds to the east as well. But it's basically a direct illumination of the sunlight reflecting on the water vapor molecules that causes this beautiful phenomenon that you see regardless of day or regardless of time of day, I should say. Common severe weather concerns that you will see to start, of course, are squalls. Squalls can be basically in the form of frequent lightning, damaging wind gusts, heavy rainfall, and reduced visibilities. One of the more concerning aspects of severe weather out on the water are water spouts, which are basically tornadoes occurring over the water. And anyone who might have observed water spouts from a distance or had a closer encounter with them, would probably be able to attest to their erratic nature, and that's what makes them so dangerous to any sailor or boater that's out on the water, because they rarely follow a straight path. Certainly they can be life-threatening as well. But gusty winds associated with strong thunderstorms, like I said, are a risk. And when you have those strong winds, you can certainly get localized higher seas in your general location. But the degree in which those seas can build is heavily dependent on the overall area that is covered and being affected, because fetch is a very real concern and phenomena out on the water. And when you have smaller fetch or a more limited fetch scenario, you're generally not going to get the same building of seas that you would when you have a larger fetch. So think of an offshore wind moving over open water closer to the coast. You're not really going to get a substantial building of the seas. But certainly other concerns that are present out on the water are lightning, of course. When you're out on the water, generally you're going to be the tallest target, unless there happens to be a larger vessel around you. So making sure that the vessel is equipped to handle any potential lightning strikes is important, given you're basically, for lack of a better term, a sitting duck. And of course, hurricanes are obviously a big concern for anyone who's out in the water, particularly in the Caribbean, across the Gulf of Mexico, Florida, southeastern United States, just to name a few off of, the Atlantic side. Or if you happen to be in the middle of the Atlantic, as we head deeper into the hurricane season, the Cape Verde island season begins to heat up as well. So those are certainly areas of concern to be aware of. Or if you're sailing in the Eastern Pacific, that's also a high risk area for tropical development during their hurricane season as well, which is largely in line with what occurs in the Atlantic. The Atlantic hurricane season runs from June 1st through November 30th. The East Pacific hurricane season begins just a couple of weeks earlier on May 15th. So basically, a hurricane, for those who may not know, it's a large storm that contains violent winds, and significant destruction can often arise from those. And unfortunately, the Caribbean is one example that has become increasingly vulnerable to powerful hurricanes in recent years. These systems tend to be more symmetrical in nature and contain an eye wall in the center of the structure. And for the strongest of systems, that's most evident. A weaker system does appear to be more disorganized, and might not have a more defined eye wall than their stronger counterparts. But it's the very warm sea surface temperatures that feed these monsters. When you have a sea surface temperature of 30 degrees Celsius, that's an ingredient that's needed for their development. Another thing is light winds aloft that prevent these systems from being sheared out and further aid their development. So as I said, areas where you're most likely to find these include the tropical Atlantic. That includes the Cape Verde Islands and Western Africa later in the hurricane season, the Caribbean at any point during the hurricane season, as well as the Gulf of Mexico. And the Eastern Pacific tends to be vulnerable from mid-May through the end of November, although you tend to see a sharp drop off heading through October and into November. For those of you who are familiar with the Western Pacific, you would know that those tropical cyclones are referred to as typhoons. So as far as preparing for hurricanes, if you happen to be considering an offshore passage during the midst of the hurricane seasons and you get wind of a tropical cyclone that's out there, it's always good to closely monitor the forecast, make sure that it's not going to pose a direct threat or any threat at all, I should say. And you could certainly get your information from the National Hurricane Center, to provide the latest advisory updates before you head out on the water. Other things to take note of are whether tropical storm watches and warnings are issued, or the same can be said for hurricane watches and warnings. So basically, for a tropical storm watch, when those are issued, it means that a system containing sustained winds of 34 to 63 knots can be expected at that given location within 48 hours. And then when a warning is issued, it means those conditions are expected within 24 to 36 hours. So a hurricane watch functions the same way as a tropical storm watch, except for the fact that it means, any system with winds in excess of 64 knots is likely within 48 hours at that location. And then that warning is issued when those same conditions are expected within 24 to 36 hours. So that lead time is important. Obviously, you would want to prepare for any potential tropical cyclones that could affect your region. And of course, make alternative plans to wait out a system in a protected location rather than being out on the water if one of these is to threaten. Now, even in scenarios where there is a system out in the Atlantic or the Eastern Pacific, wherever you may be, you may not be in the direct line of fire for these systems, but oftentimes very large and long period swell can emanate from these systems towards your location. So we'll talk a little bit more about that here in more detail soon. So as far as going into the actual preparation for your passage, of course, knowing what your plans will be is essential. As far as what conditions your vessel can handle, yes, that's important. As far as knowing what your crew is capable of handling or what they prefer for tolerance levels, that's even more important. Obviously, safety is the number one goal and priority, but obviously comfortability is a strong second priority as well. Being prepared for a mixed bag of conditions that you would experience on a longer passage, will be important to prepare for and can make the difference between a great passage or an uncomfortable one, or one that requires you to make alternative plans to stop somewhere. So basically, you want to know your vessel through and through. I kind of liken it to someone who's just getting their driver's license and learning how to drive a car. You want to know the size of your car and know the car through and through as well. But you basically want to know what the vessel can handle, what are its limitations and strengths. But it all ties back to, knowing what the tolerances of the crew is. Crew sensitivity, it's best to understand who the quote unquote weakest link might be, if you will. So in other words, if a particular crew member or two tends to be more conservative on what they prefer to experience out on the water, that's something that's, strongly encouraged to be of consideration versus, a situation where, it's basically the weakest link is the route you would want to take versus what the highest level of tolerance would be, just to make sure that everyone is comfortable on board. So don't be afraid to be conservative with with the constraints while going out on the water, to make sure that everybody is safe and comfortable. One other thing too, when preparing for your trip, and especially for those offshore longer passages, you're going to want to make sure that you have backup plans to bail out if the weather gets uncomfortable. Because one of the limitations of sailing vessels in particular versus motor vessels is the fact that they're limited by their speed or lack thereof. So a motor vessel might be able to speed up ahead of an approaching cold front and inclement weather. The same can't be said for sailing vessels, which are naturally slower than motor vessels and have a more limited fuel range. So consider all your scenarios to make sure you're in a spot to be able to outrun or stay ahead of approaching systems. But unfortunately, there will be times where you do encounter the rough weather and it will be unavoidable, and you'll need to make the preparations to handle and proceed through those conditions in those instances. So again, is the vessel equipped to handle rough weather on longer passages? It's good to have a plan in place with the crew to make sure that everybody's all on the same page to prepare for the heavy weather. But identifying what that heavy weather is, especially when you're out on the water, and using the sky as a barometer for what might be out there is important. No two heavy weather situations, of course, are going to be exactly the same. So you need to be prepared for all those scenarios and how they might pan out. For example, one time you might have thunderstorms producing strong winds and frequent lightning. Other times there might be scenarios where there's a higher risk for water spouts. So, being able to, in the case of the latter, having diversion abilities and understanding where the water spouts are going, it's important to be able to, route around these concerns to mitigate any potential risks to the crew and the vessel. And of course, you do want to make sure that you are aware of what the vessel can handle, which may be more than what the crew would prefer to tolerate while out on the water. So it all comes back around to what the crew can handle, and just having the diversion techniques needed to avoid any significant weather concerns. So, preparing for changing weather. Unfortunately, when you're out on the water, this is something that's going to happen. No matter how seasoned of a sailor you might be. And the key is, of course, like I said, just having the plan to avoid it, or at least minimize it. But there are clues that can give you the best knowledge possible to avoid it. And what you need to do is take a look at what the warning signs might be for that developing inclement weather. Cloud cover, as we discussed earlier, is one of the surefire signs of changing conditions. But there are other things that go along with it too that can help clue you in on changing weather conditions that are not for the better. One such instance might be a drop in the surface temperature. So if it's getting cooler and you notice an increase in cloud cover, it might be indicative of unsettled weather and a front approaching. Other times you'll get gustier winds. And if the front tends to be on the stronger side, you can certainly get gale force gusts in the strongest of scenarios. Or if there happens to be a nearby gale, certainly even stronger winds than that are a possibility. But if you notice an increase in precipitation while out on the water, obviously that's a very surefire sign of inclement weather. And very intense rainfall as well is going to be, a fail-safe identification of said severe weather. You might recall the brief discussion about changes in pressure from the Weather Basics presentation, where decreasing pressure is an indication in deteriorating weather. So that can be another sign as well that conditions are more quickly deteriorating. But take into consideration the rules that we discussed, the 1, 2, 3 rule, which indicates there are changes for the worse, but it's not as immediately imminent and something to be mindful of, versus the 4, 5, 6 rule, which indicates a more substantial drop in pressure and thus more immediate action is needed. Now, certainly the sky is one of the top, indicators of changing weather conditions. But, you also want to take a look at what's going on the water as well. And this is especially the case, at night, when your ability to see what's present in the sky can be severely hindered. So take a look at the seas as well. You want to take a look at the wave height. Are the seas benign? And if so, the weather's more likely to be benign as well. But of course, if the waves are building and you notice a gradual building of the waves with time, that's certainly an indication that, there might be more inclement weather on the horizon. Take a look at the periods as well. When you look at a longer rolling swell moving across your region, that too might not indicate that there's imminent severe weather or hazardous weather on the horizon, but it can at least clue you in that there's a distant front, potentially a distant gale, or in a worst case scenario, a longer distance tropical cyclone that could be emanating those larger swells that are longer period over your location. The directions of the waves also are a big one. And certainly when you do get waves coming from multiple directions, that can be the combination of strong gusty winds driving up the seas, which tend to be shorter period coming from, say, the northeast, but a longer period groundswell coming from the southwest. That can indicate a very confused sea state, meaning that there are unsettled conditions nearby. So sky cover, of course, is certainly not the only tool you can refer to. But there certainly are more limitations, especially at night, when you don't have the same visibilities that you would during the day. So when conditions are improving, basically, as we've talked about earlier, increases in visibility will tend to mean conditions are improving, and that can result from a decrease in precipitation and resulting intensity. And that also can mean an increase in temperatures and a decrease in cloud cover. So if you see the sun moving out of the clouds, those are all good indicators that improvement is on the horizon and better skies are ahead. Furthermore, when you see the sea state also calming down, that's also a good positive indicator that the conditions are improving as well. So certainly technology has gotten better over recent years. For example, with the development of Starlink, that allows you to have more access to phone communications and access to radar while out at sea. But of course, that might not always be the case. So it's important to have knowledge in these clues because of those limitations that can develop while out at sea based on a lack of radar. So taking a look at the skies and the sea state and having a firm knowledge on what the changes might mean can be the difference between a successful cruise and, certainly one that involves severe weather or far from ideal conditions. And basically having that knowledge in the case of an absence of radar, it basically increases the safety for all on board. And if there is severe weather on the horizon, it also assists with the preparation for that. So obviously safety first is the bottom line, regardless of when you're sailing, but especially it's critical at night because it becomes more difficult to identify hazardous weather with the naked eye. So having that plan to ride out the severe weather is important, especially if you are not able to avoid it. So clues you can look for at night when being able to read the clouds becomes more challenging is knowing what direction the wind is coming from. So, for example, if the wind's coming from the southwest, that might be indicative that there's a cold front coming. If there are thunderstorms nearby, is there lightning visible? So using the direction of the wind can help give you an indication as to which direction any storms might be moving. So you'll want to take a look at your location relative to the direction of the wind and any storms that might be out there to determine whether there is a path to stay ahead and avoid the heavy weather, or if you need to hunker down and prepare for the approach of it. But basically at night, you want to be able to also take a look at the sea state if able. Understand, of course, at night it might be a bit more difficult to determine which direction the seas are coming from or to be able to get a read on the actual sea height. But, knowing what the sea direction and the wind directions are, coupled with any other clues that you can get from the sky, such as lightning, can help mean the difference between successful sailing passages or unsuccessful sailing passages at night that involve severe weather. So we're going to go into more detail about some areas, particularly in the southeastern U.S. and Caribbean, that are more of a concern, that can be challenging for sailors in those areas. But we'll also touch on a couple of West Coast locations off of California that are also notoriously challenging. But the Caribbean areas tend to have a lot in common. So we'll go into more detail on these here. Some of the concerns that can result from heavy weather in these locations include severe winds, squalls, as well as hurricanes. Water spouts are also not uncommon, unfortunately, in these areas. But these are just a few areas where sailing can be challenging, and it's just simply because of the fact that, the weather patterns in these parts of the world are naturally unfavorable. So some of these can be determined by the synoptic setup, but others can be further impacted and enhanced by terrain differences. So we'll go into more detail about that here in the slides ahead. But some of the areas we're going to focus on include Florida, Hispaniola, Colombia, the Bahamas, as well as Cape Hatteras, and then on the West Coast, Cape Mendocino and Point Conception. So Florida, one of the biggest concerns is during the summertime. You get those sea breeze fronts that develop given the notable difference in land and sea surface temperature. These sea breeze fronts work as a convergence zone and are strongest during the peak of the heating of the day. And because you have that convergence zone, that serves as a focus for thunderstorm development. Now, thunderstorms in Florida during the summer months in particular are so routine during the afternoon, you literally could set your watch to them, occurring during the mid to late afternoon hours, but then they tend to weaken and dissipate after dark with the loss of daytime heating. But you can see in this example here, there certainly are numerous coastal thunderstorms emanating from those sea breezes. And then usually what happens is they either remain stationary near the coast or they push inland as that sea breeze also works inland from the coast. So proceeding across the Gulf Stream can certainly be very challenging, depending on what kind of conditions you are planning to depart in. As you know, it's a pretty substantial current off of southeastern Florida in the Florida Straits that can make passages to the Bahamas either a cakewalk or very difficult and require you to have alternative plans. Usually with the Gulf Stream, you might recall from the weather basics discussion, larger currents tend to not be as affected by major weather events as tidal currents are. But certainly the sea state can be affected by larger weather events in these areas. So because the current is a strong current moving northward, anytime you get a strong northerly wind coming from the north in the Gulf Stream is going to be a not so good situation. And usually the result is the stacking of seas that tend to be stronger, or not stronger, but shorter period. And they can become quite elevated and enhanced, sometimes in excess of 10 feet. So think of a stacking sea in excess of 10 feet. Not a good situation. Basically, this is a phenomena that's especially common during the winter months when you have the fronts tending to be further south and stronger ridging building in their wake. It can happen during the summer months as well, but usually the ridges that move across this region are weaker. And given the front trajectories tend to be further north during the summer months, you're not going to see as many of these northerly scenarios during the warmer season. But with that said, it can still happen. The winter months tend to be the time of year where this is especially challenging. And you can find that these northerlies to northeasterlies prevail for the period of several days. Hispaniola is another very tough area of the world to transit in. And really on both sides of the island, you tend to have the concerns with enhanced easterly winds. But this is especially true along southern Hispaniola on the southern tip called Cabo Beata. So funneling winds tend to happen both on the north side of Hispaniola and the south side, which I should further describe as the combination of the countries of Haiti and the Dominican Republic. Cabo Beata tends to have very strong funneling easterly winds within strong ridging, but these easterly winds can also prevail in similar setups to the north side of the island, although these tend to not be as strong as further south. In any case, seas in both locations can be quite elevated and enhanced. And when you have, the seas enhanced from the winds, between Haiti and the Dominican Republic, you can get some very short period seas. And these trades can last for days on end. As we get into the winter months, they become more common as the Christmas trades begin to settle in. So you would typically want to rely on a cold front shifting off the coast of Florida and into the Bahamas to break that ridge down and thus make for favorable conditions, during the winter months when you make travel through here. Haiti and Dominican Republic are also no stranger to hurricane risk, unfortunately. Basically any time of year from May to June when the season officially starts, and then onward tends to be when you can see the development of these systems. But certainly July through September and October is when there is the greatest risk, because earlier in the season, the risk tends to be further west across the Western Caribbean and into the Gulf of Mexico and Florida. One of the compounding factors that tends to be an issue for sailing in these areas as well, south of Haiti and the Dominican Republic as well as north, are the currents. But unlike the Gulf Stream, when you get the northerlies, you tend to have the currents moving in the same direction as the winds are coming from. So while the seas do become locally enhanced because of the stronger current that's occurring south of Cabo Villata, and also north of the DR, you won't see the same enhancement that you would see off of Florida in that northerly regime. But it's worth noting that the current is particularly strong. So when you get those easterly winds and you're heading east, and then you have that unfavorable current, it can make for a slog when you're traveling in any of those areas. So next, we'll move on to Colombia, which is another area that is frequented in the Caribbean for vessels that are particularly headed to or leaving Panama. Obviously, when you have, here in Colombia, you have a lot of the same concerns that develop, along northwestern Colombia that you would have on, the Dominican Republic and Haiti. You get the northeasterly winds that develop and results in short period seas stacking closer to the coast. When you have that, it's a process known as shoaling. The combination of the strong winds and seas is fueled by the interaction of strong ridging and thermal troughing. But when the ridging weakens and broadens from a cold front moving across Florida, you tend to see the northeasterlies weaken. And this tends to happen during the winter months. One of the other phenomena that you tend to have along Colombia results from the winds that develop over the Sierra Nevada de Santa Marta. It's a very tall mountain range inland of Santa Marta, which results in a phenomena called the katabatic winds, which result basically in winds that are shifting downward along the northwestern facing slope of the mountain. And the momentum then of those winds is what further aids its speed, and then it shifts offshore. So the combination of the thermal trough and the ridge and that katabatic wind effect tend to result in the enhanced northeasterly winds that you experience off of northwestern Colombia. So the good news, at least for this region, and certainly there's a lot of tough routing concerns here in this part of the world. But the good news is that hurricanes tend to not be a problem in Colombia, at least on the northwestern side. The biggest risk from hurricanes and tropical cyclones in this region of the world happens to be from larger swell that might emanate from one of these tropical cyclones. But they generally pass to the north and northwest of Colombia and are otherwise not a concern for this region. And the same can also be said for Panama. So the Colombian current has a significant role as well in the sea state along northwestern Colombia. And basically, a similar phenomena plays out here along coastal Colombia that plays out in the Gulf Stream when you have a northerly wind. The biggest difference between the Gulf Stream, northerlies in the Gulf Stream and the northeasterlies here off of northwestern Colombia is that in the Gulf Stream, the northerlies tend to be more variable and the pattern tends to not remain stagnant. Unfortunately, that's not always the case along northern Colombia and northwestern Colombia in particular. And you have that stagnant setup of northeasterly winds, and you have the northeastward moving current. So when we talk about the stacking of seas that occur offshore of northwestern Colombia, it's also aided in part due to the Colombian current that exists with this ribbon that you see extending off of the coast. So generally, anyone who is routing in this area, you would want to consider a bit of more of an offshore route, to get a better current assist if you're heading towards Panama, but it also keeps you out of those shorter period seas that might become more elevated and stacked because of the shoaling effect. So moving on to the Bahamas, obviously similar to Florida. One of the concerns here is obviously the tropics, and obviously there's a great risk for hurricanes across this region of the world. That tends to be the case basically August through October with the greatest risk period. Here in this part of the world, systems tend to be emanating from the tropical Atlantic and then also the Cape Verdes. So usually systems tend to track towards the Bahamas or the Caribbean, and thus that is the greatest risk time for those for the Bahamian Islands. Absent any tropical concerns, though, you tend to get the Christmas trades effect during the winter months, um, which tends to be a period of enhanced trades that can last for up to 1 to 2 weeks without any significant change. When you get a strong front, like I said, moving off the Florida coast, that can break down the ridge. That also then helps to ease the Christmas trades. Um, the Bahamas can also be a challenging place to route as well, simply owing to the fact that if you were coming from Florida, for example, you're not exactly going to have the most favorable wind angles, which are generally out of the northeast to east. So you might find yourself in a situation where if you're coming from Florida, as an example, you're going to be tacking for parts of the passage. One of the other concerns in the Bahamas is the fair number of shallower waters that you would encounter, and that includes over the Exumas Bank, Blossom Channel, which is south of the tongue of the ocean, then also the Little Bahama Bank, or even if you were to be on the Great Bahama Bank. Those are areas where, if you're not comfortable with being in shallower waters, that can pose challenges to you as well. But assuming you are comfortable with those shallower waters, of course, working your way north and south in the Bahamas can provide some great opportunities for sailing when the trades are stronger. And then if you are comfortable with being over the banks, that can also help to hinder some of the largest seas, given the shallower nature of the waters. So the Bahamas kind of offers a mixed bag of sailing opportunities. Obviously, there's the inherent risk with the tropics, but during the winter months, it's a great place to sail if you're comfortable with sailing over the shallower areas, such as in the Exumas. But of course, that would be a bigger drawback, or a drawback being that if you were to come from Florida, you might be looking at enhanced northeasterlies that require you to tack. So on the East Coast, Cape Hatteras is obviously another area of concern that involves funneling conditions. A lot of the concerns here involved with front passages tend to also play out. Now, granted, front passages year-round tend to be more common here than they are in South Florida. During the winter months, the enhanced ridges building off the coast with these fronts tend to be more common. But during the summer months, frontal passages, like I said, are more common here than further south. But the subsequent ridging that builds off the coast tend to be weaker. With that said, you get the funneling of the southwest winds in advance of a front as you round Hatteras, but in the wake of the fronts, you tend to get the enhanced northeasterly winds. So the Gulf Stream can certainly pose problems here in offshore of the Eastern Carolinas, given that you do have that northeastward moving current. It's worth noting that the overall ribbon tends to be a bit slightly further off the coast than the immediate southeast coast of Florida. But anytime you get a northeasterly wind, if you do happen to get stuck in the Gulf Stream, you're going to notice those enhanced northeasterly winds. So you certainly would want to have a southwesterly wind rounding Hatteras, but the problem then becomes, are you routing south or are you heading north? In the case of the latter, that would be the better scenario to encounter those southwesterlies ahead of the front, which then would give you some lee protection coming up around the outer banks. But definitely similar to all the other areas that we've talked about, there is at least an inherent concern with respect to the currents and the winds, but it's conditional on the direction of the winds, of course. So Cape Mendocino tends to be a location where the northwesterly winds tend to be most significant during the summer months. And this is driven by the very sharp temperature difference along the mainland of California and also the cooler offshore waters just offshore of Mendocino, creating that temperature gradient and thus further enhancing the northwesterly winds here. As you can see, though, that Mendocino kind of sticks out, which causes a bit of a momentum in allowing the winds to funnel around Cape Mendocino. So if you're heading south around Mendocino, it's not as great of a concern as if you were heading north, but obviously those enhanced winds do pose a challenge, and certainly during the summer months, they can last for weeks at a time. So that's certainly something to be mindful of. Um, Another concern along California is the presence of dense fog, and this can often be a concern during the summer months. Again, when you have those temperature differences over the mainland and then over the open waters further to the west. The good news, at least, though, unlike in their Caribbean counterparts, the tropics are not a concern here, not even in the form of getting longer swell emanating up the California coast. So no issues with respect to tropics there, but you do have to be mindful of those northwesterlies, which can become enhanced during the summer months. And certainly you can get southwesterlies during the winter months when you get further front passages to the south across Northern California. Oops. So a lot of the same concerns also persist at Point Conception, from funneling northwesterlies to dense fog in coastal areas. The biggest differences here at Point Conception versus at Cape Mendocino is that the overall duration of the strongest northwesterlies tends to be a little shorter lived in nature because the thermal trough tends to be broader here. But certainly they can still pack a punch. And just like at Mendocino, where gale force winds can occur, they can likewise occur at Point Conception. But given the axis of the thermal trough near Point Conception, those winds often tend to cut off as you get further east into the Santa Barbara Channel. But they can certainly spill into the western part of the Santa Barbara Channel when that thermal trough is strongest. Tropics are not a concern here. The biggest difference is that, if you do get that rogue tropical cyclone working its way up the Baja coast, you can get that distant long period, swell that can spread over this region, but a direct impact to Southern California is extremely rare and really not a concern. So one of the phenomena that occurs in the Caribbean, particularly, as we discussed with Colombia, katabatic winds are basically a wind that's influenced by gravity. Whenever you have a sharp elevation gradient is when it tends to be more pronounced, because when the winds are influenced by gravity, the wind is pulled down to the surface, if you will. And because it has that momentum, obviously the wind becomes more enhanced. Now, these winds can persist at any time of day, but they tend to be most common during the overnight hours. And so they are, in a sense, a downslope wind, which involves the winds descending from the top of the significant elevation to the ground, and gravity plays a significant role in that. So obviously, the Santa Marta, Sierra Nevada de Santa Marta is a classic example of that, but you don't need to have substantial elevations in the mountains over shorter distances to have that enhanced wind. You could be sailing between the islands. For example, Capri in the Mediterranean, you can get that same effect. Or if you're in the Caribbean, obviously there are some higher elevation mountains in some of the Caribbean islands that you can get that katabatic effect as well. So you're not limited to a particular part of the world where these occur. They can occur anywhere you have sharp changes in elevation, and you have the presence of abundant wind. And the Caribbean is a good example of that during the winter months when the trades tend to be particularly strong. So as far as helping to make informed decisions with respect to the forecast, obviously there are a variety of weather-related apps you can use to assist with determining the best days and times to make your crossings. And as Hugh said, it's definitely great to have multiple resources. You don't want to limit yourself on, to one resource or another. It's great to have a variety of resources to make an informed decision. But some of the more common ones that you might find include Windy and Predict Wind. One of the more notable ones recently that's come available is Time Zero, that allows you to evaluate weather conditions. One of the biggest drawbacks to some of these, these weather resources is the fact that they lack the human element. So you can read a weather model and it'll give you an output, but unfortunately, weather modeling is an imperfect science. So they're going to be subject to error. And this can happen in areas where terrain has an outsized influence on the overall weather pattern. So the Mediterranean is a classic example of that. Sometimes in the Caribbean, when you do get those katabatic winds, the models don't always pick up on that. So the models might actually show lower winds than what you ultimately will encounter. So, certainly that lack of human element would be one of the more significant limitations, to um, constructing an accurate forecast. But constructing that accurate forecast, of course, is important to making sure that you have your plans in place for offshore sailing, and having contingency plans to stop if needed. If you're going to be making a longer offshore passage, you need to prepare for scenarios where, there might not be good winds to sail, or you're bashing into head conditions and you need to motor. So having an ample fuel range is a good and important, step that you need to take before you get underway to make sure all of your bases are covered. And of course, having that plan B to stop if needed. So one of the things that I do here at Weather Routing when obviously I work with our clientele to help them find the best windows to get from point A to point B. And we do have the human element, which allows you to work with our degreed meteorologists. And so, we can certainly assist you with these plans. But basically, what we do is, we provide forecasts that are customized to your specific needs. The good news, we do forecasting worldwide. So whether you're sailing in the Caribbean, the Mediterranean, or even the South China Sea, for example, we've got you covered. As far as the human element is concerned, one of the things that we have with our experience is pattern recognition. So basically what that entails is being able to recognize different weather patterns and understanding what's happened in the past with those same weather patterns to be able to construct an accurate forecast when the models may not be as accurate. So also having that human element gives you the opportunity to ask questions about your window and to strategize best options to help you get from point A to point B, or if you need to make contingency plans to stop along the way or even delay. So we customize the forecast to your specific needs. What I mean by that is, you would tell us what winds and seas you'd be most comfortable with out at sea. And if the winds and seas were to be higher than, what you would, advise for thresholds, we wouldn't validate such a departure, and instead we'd provide you with those alternative options. But we want to work with you. Obviously, safety is the top priority, but we want you to be comfortable as well. Because being able to enjoy a comfortable sail is very important to us, and we want to make sure that you're getting the most out of your trip as you initially set out to do. So you can see here in this image to the right, this is an example of what our sample forecasts look like. It's a breakdown of the timestamps as well as the wind and sea directions, and the magnitude of the winds and the sea state. So one last thing to tie it all together is to consider the resources available to you. It's always good to consider the reputation of the provider that you go with. Consider their accuracy. Do they have a good track record, in the field of meteorology? That's important. Of course, further to that, making sure that they have the dedication to the science of meteorology. Are they degreed meteorologists? That's important too. Accessibility, very important as well. And in the case of Weather Routing, we're available all hours of the day, all hours of the night, regardless of the day, on any holiday. So if you have any questions about a forecast or need assistance, we can provide you forecast information very quickly. And then the reliability as well, knowing that you can count on your source to be able to provide you timely and accurate forecasts in a very reasonable manner. And if you happen to be looking at local news channels, take a look at what's on the news. Scrutinize the on-air talent and see if they do have a working knowledge of the location that they are forecasting for. Because as we know, weather that governs Phoenix, Arizona, for example, is going to be further different than weather that governs Raleigh, North Carolina. So you're going to want to have someone who is knowledgeable in all aspects of the weather coverage area to make sure that they are providing you with the most accurate forecast. So to end the second part of the discussion, we do offer a supplemental program called seaweather.net, which we had talked about our customizing routing and forecasting services, which allows you to work with our degreed meteorologists. But SeaWeather is a great independent planning service that allows you to plot out routes on the Voyage Planner against the various weather parameters. And one of the reasons where this service sticks out versus Predict Wind and others such as Windy is that basically when you use this service, you have access to several unique features such as Tropical Tracker that gives you daily basin summaries and also any updates on tropical cyclones. We do offer information on systems we believe that are going to develop into strengthening tropical cyclones to get ahead of the national hurricane season and get you further heads up on any potential tropical development in the days ahead. But it also allows you to evaluate routes that we have put into our system so you can see our thoughts as well. So for those of you who have attended tonight, I did just want to let you know that we do offer a complimentary forecast to all of you who have attended. If you did wish to try our services out, feel free to give us a call or send us an email at both the phone number and email address you see on file on this slide here, and let us know that you learned about us from Deb Marler's webinar, and you will receive a coupon number which will entitle you to a complimentary forecast as well as a 30-day SeaWeather trial. So with that, Hugh, I will go ahead and turn it back over to you.
All right. Thanks, Alex. Great job. Really appreciate you doing this presentation.
Thank you.
And so let's open it up for questions for a little bit. Anybody have any questions?
Yes, so Stefan, I do have a question.
Hey there.
Hey, how are you, Stefan?
Hey, Alex. Thank you, first of all, for your summary. Really great. Very much appreciated here.
Absolutely, my pleasure.
If you would need your service, how much would that be for a forecast?
Thank you for the question. So for the forecast itself, one of the things I'll elaborate on first is that we charge on a per forecast basis. So it's not per trip. A single forecast is $100. But one of the things I think it's worth mentioning is that it's the customized routing and forecasting service is not a subscription-based service. So what I mean by that is, you could request a forecast in a day's time and then not need something for 2 to 3 weeks after the fact. So you would only be billed for that one $100 forecast, and you wouldn't be incurring any fees in between. And we do keep all of your information on files, so there's also no fee associated with having an account with us. But you get basically access to our degreed meteorologists to discuss any questions you might have with the forecast, that 24/7 availability, and a detailed overview of our recommendation for a passage from point A to point B, and any recommendations we might have if the window doesn't look favorable.
Okay, well, thank you very much.
Thank you for the question.
Thank you for your presentation. Great.
My pleasure, Stefan. Thank you for the question.
Since I'm on, maybe I can ask as well. It's not a particular question for Alex, but maybe for the more experienced sailors. What instruments do you have on board for weather forecast? I mean, is there any particular that you would recommend?
Well, I mean, it's a really great question. It's also not a question that has necessarily a simple answer. And the reason is that instruments are tools, and the kinds of tools that you may need, this level of sophistication for those tools is highly dependent on where you're sailing. So, for example, if you're day sailing, you're going into an area where you probably know where you are, you recognize the coast, the landmarks, you're not worried about knowing how to get back from where you left. if you're sailing up and down a coastline, like where take Hatteras, for example, you're going to want to make sure that you have equipment that's going to let you see things like other boats that are out there, like AIS and radar for say and Doppler radar to see the weather. Because Hatteras can be a very treacherous rounding. There are even shoals that stick out almost 100 miles. So again, and then if you're crossing an ocean, you're going to have different you'll have different instruments as weather and also different supplies like a different type of raft versus and one of those instruments might be an EPIRB so that if you're out in the middle and you have to leave the boat or something. And there's various manufacturers. You have B&G and Raymarine and Garmin. Most of their plotters are generally like a tablet these days. They're touchscreen. But they have their own differences and nuances. For example, B&G, if you've ever used Navionics on a tablet, B&G, you can buy a SIM card, a card that goes in the B&G, and your B&G plotter will look exactly like your Navionics tablet. So that you're using your tablet, you can send the routing over to the plotter, but the two displays look virtually identical, which is kind of a nice thing. Where Raymarine and Garmin, they'll use Navionics data, but they display it a little differently because they want to obviously be different, and they've got reasons for doing that. And so there are personal preferences on the types of instruments that you get. And there's also, do you have a plotter in the cockpit versus having one down below at the nav station, and can you exchange plots and routes between those two? You can buy a lot of instruments and do some very expensive instrumentation, but it doesn't mean you have to. And so it's I mean, even down to the level of your wind vane at the top. You can run a cable all the way down the mast, or you can buy one from companies that it's a Wi-Fi connection, so you don't have so it's a nice installation. But at some point it may fail, so then you have to go up the mast and fix it. But but it's something you want. And Starlink is another example. It's an amazing tool that now has virtually become indispensable, because if you're out on, even if say you're overnight sailing and and you think you're looking for weather fronts or something like that, and you can go to WRI, you can go to Windy or whomever, all three, and get up to date. You're no waiting for GRIB files anymore and hoping they get downloaded over a SAT connection or something like that. And Starlink is interesting in that, originally was quite expensive. It's come down in expense, and they keep making it faster, which means it just makes other instruments like your plotter can have up-to-date charts all the time. So you go to the Bahamas and somebody says, well, they had a storm 6 months ago and things shifted. Well, now you're going to have the most up-to-date information, because Navionics and Aquamaps, they're all getting real-time data from people, and it gets updated, and and of course there's a cost to it. And one of the things that that we talk about a lot in the course of Comfortable Cruising is about those things. How much do you really need to spend? How much do you want to spend? What makes cruising comfortable? If you have good, solid instruments that provide you information that's useful, then you might decide it's worth spending. It's the same for water makers and solar and lithium. There's always a thing about you buy a water maker and somebody says, well, you'll never get your money out of it. Who cares? I can anchor and make water anywhere I want. I don't care what it costs. Or an instrument that is fully usable when it's raining and it's nice and big and it's bright and I can use it, versus the small little display that is hard to read. The two products are very different price range, but you have to decide what's the use that you look at and you say, it's okay, I spent more, but I got so much more out of it, and it made my cruising that much more comfortable. And so the webinar on January 7th, my wife's going to talk a lot about that, about what things you don't need on a boat, why you would do this, why you would do that, because it's different for everybody. And then every boat's different, right? Where you mount displays, big displays, the little square displays and all that kind of stuff. And then again, solar versus lithium and how that affects your instrumentation, right? I mean, if you're sailing, and you're not running the engine and you have lithium and you have solar, that's a completely different thing than AGM, which once it gets to 80% or 10 volts, it shuts down. Well, lithium doesn't do that. Lithium's expensive. There's no way around that, but it just does so much more. So it's that's why I'm saying it's such a long question, and it's a great question because there's so many things to think about, which, it can be fun because there's choices. And all these instruments, they work with each other because they're using N2K as the network backbone. So you can get a Garmin this and a B&G that, and they all talk to each other.
Okay. Well, thanks very much for this very long answer. Thank you. Yeah.
Sorry. Any other questions? All right. Well, just one last thing, I quickly, the next webinar that my wife is doing is called Comfortable Cruising, and there'll be, weather will be talked about, instrumentation, water makers, solar, all the things that you can be considering and looking into if you're going cruising, and how to make it comfortable and enjoyable at the same time. And that's on January 7th, and there's a coupon code here on the screen that you can attend for free. Want to thank everybody for attending. Alex, thanks for the great presentation. I think it was really helpful. And I think you've got the websites here if you have some questions and follow up, and we look forward to hearing from you.
Thank you, everybody, so much. And Hugh, thank you for doing such a great job moderating tonight. It's been nice to put a face to the name. So thank you again for everything, and it's been a lot of fun.
No, I'm actually an AI bot. I don't really exist.
You be well. Thank you again so much.
Good night, everybody.